Alright, on this last video we're going to take a look at an ellipse that's oriented vertically. And that just means it's longer vertically than horizontally. So let's, using what we've learned in the last two videos, let's take a look at the denominator that's the largest, and that would be the 64. Well, we know that when we find the largest denominator on an ellipse, this only works on an ellipse. It's not true on the hyperbola, which is the 7-3 information. But on an ellipse, I look for the largest denominator, and I know I've found my a squared. Okay, so then my a is 8. Easy. Let's go to the b squared, which is 36, and b is 6. All right, so now, because the center is off from the origin, it's off the origin, it's not right on the origin, then let me name the center, and that is 3, -2. Okay, remember that's my h and that's my k. All right, so here's my center at 3, -2. Let's go ahead and put that on here. We have 3, -2. Now, the a, because I know this is oriented vertically, how do I know? Because the large one is under the y term. Then I'm going to go 8 up and 8 down from the center, right? Because it's oriented vertically. I'm going to, with my b, I'm going to, from the center, I'm going to go out 6 in each direction horizontally. Okay, pretty simple. All right, so let's go ahead and let's make those movements. Up 8. There's the uppermost boundary. And there's the lowest boundary. Okay, we're going to go 6 in each direction now. There's that. And there's that. Now we're going to go ahead and make our sketch because it does say to graph it. Then we're going to find our foci, whatever you want to say. Actually, did find out you could say it either way. I say foci for some reason. Okay, so it looks kind of like a circle, but it's not. It's a little oriented. It's a little longer vertically. So let's find the foci. So c squared is equal to a squared minus b squared. So 64, excuse me, c squared is what we don't know. C squared is equal to 64 minus 36, and we find that c squared is equal to 28. That's what I thought. I had to double check it. So then my c is, now that's square root, and really there's a perfect square hidden in there is a 4, so I'm going to bring that out. That's 2 square roots of 7. Normally we would have plus or minus, but because it's a distance, we're just going to keep the plus. So then we get c is roughly, what is that, 5.8-ish? My bad, 5.3. Okay, 5.3. So I'm going to go out. Now, which direction do I place? Which direction do I go with my c? Well, it's oriented vertically, so I'm going to go up 5.3. 1, 2, 3, 4, 5. There's my focus right there. That's F. And then down 1 from the center, not from the origin, from the center. 1, 2, 3, 4, 5.3. There's my focus. Now, the last thing I want to do is want to name them properly. I can't just use that decimal. That's an approximation. I want to be exact. So let's think about this. In order to find the places where these foci are located, I need to go out 3. Okay, so it makes sense that my x-coordinate is 3. Now, let's go down first. I'm going to go -2. But I'm also then, on top of that, going to go the -5.3, which is 2 square roots of 7. So think about it. I'm going to go -2 minus 2 square roots of 7. That'll get me to the exact location of that focus. All right? In like manner, and we're going to go over 3 for the other focus, and we're going to take -2, now let's think about it, -2 plus 2 square roots of 7. That's going to give me the location of my focus right here. Now, let's just make sure that this one here makes sense, because it's kind of weird the way we're taking -2, going in the opposite direction. But I have a -2 plus the 5.3, And won't that mean that I'm going to go up 3.3? And isn't that the place where this focus is located? Over 3, up 3.3. So it does make sense. It should be intuitive. It should make sense mathematically, that type of thing. Well, actually, it might not be intuitive, but it makes sense mathematically. So anyway, let's take a look at the next equation. It says just to graph the conic. Now, this they're not telling me what kind of conic. Now, we've looked at parabolas, we've looked at ellipses, and in this actual video I'm going to talk about circles. But let's go ahead and proceed, and as if all of them were mixed up and we don't know what this is going to be. I'm going to go ahead and pull all my x terms up to the front, just because that's kind of my habit. I'm going to leave a space. I'm going to put the y terms next. I'm going to move the 256 to the other side. All right, here we go. I'm going to factor off the 9. I'm going to factor off the 25. What is that, 8? And lastly, I'm going to give myself spaces because I know that I'm going to put numbers here and here. Therefore, I want to put numbers here to compensate. For putting them on the left, I need to put the equivalent number on the right. Not necessarily the same number, but the equivalent value. Okay, so let's see. Half of 6 is 3 squared is 9. So I'm going to place a 9 here. But the reason I'm not going to put a 9 here is because I didn't really place a 9 on the left. I really placed a 9 times 9. I really placed an 81. So I'm going to put an 81 here. So if in other words, if I remove the parentheses, what's going to be in that third position right here, right? What's going to be there is going to be a 81 that I really put in that equation. So I have to put that on the right side. Same thing with the green one. Half of 8 is 4 squared is 16. But I'm not going to put a 16 here. I'm going to put a 25 times 16. And 25 times 16 is 400. So that's what's going to go on the right side. Now let's clean this up a little bit. I get 9. I'm going to factor that. And I'm going to go ahead and consolidate it. 25 y, it looks like it's plus 4. And let's see what we get on the 225. Now, at this point, we're ready to get the right side equal to 1. In other words, that's my goal. Even if I don't know if this is a circle or an ellipse. Now, you know it's not a parabola, right? Because both of the x and the y are squared. So if it's a parabola, only one could be squared. So let's clean this up again. I'm going to basically take this fraction and reduce it. And that fraction reduces to 9 goes in there once, 9 goes in there. What is that, 25 times? So that's going to be a 25. Same thing here. I'm going to reduce that fraction there. So I get y plus 4 squared over, what is that, 9? Okay. Now, this looks like an ellipse in standard form, which it is. So let's take a look. Let me see what they wanted us to do to graph it. Here we go. So my A is 5. My B is 3. Now, which way is this oriented? Well, look for the large one. There it is, 25. How do I know that this is not a circle? The way I know this is not a circle is if it were a circle, my A direction and my B direction would actually be the same distance. Okay, they'd be the same because it would be a circle where the radii, all the radii are the same. So let's go ahead, first of all, and get the center on here. Let's go get our center. This is 3, negative 4. I'm going to show you an example of finding a circle next. So 3 and then negative 4, 2, 4. There's my center of my ellipse. And I'm going to go, remember, this is oriented horizontally, so I'm going to go, my A is going to be over 5 from the center. There's my rightmost boundary. There's my leftmost boundary. Upper boundary and lower boundary. There's my ellipse. Now let's find the foci. Doesn't say to, but I'm going to, actually I'll probably just set it up for you. we just know that 16, so C is 4. We can find them pretty easily. 1, 2, 3. There's my focus on that side. Here's my focus on this side, and you can figure out very easily where those are located by name them. So let's go ahead and do one more, and this is actually going to be a circle, but let's just say you started off and it was in the middle of a test you were taking over this stuff, and you're like, I don't know what this is. So I would just proceed, first of all, to look and see, hey, I have x squared and y squared, and the fact that both the coefficients of the x squared and y squared are the same means that it's a circle. But let's look at why that is. So first thing, I'm just going to pull off the 16. Let's say you don't notice that. So that's 2x. And then I'm going to pull off the 16 of this one. And that's a 4. And then that's equal to negative 16. So now, let's go ahead and add something here, here, and here. Alright, so that would be a 1, but that would be a 16 here. This would be a 4, but it would be a 64 here. Okay, so x minus 1 squared, 16, plus 16, y plus 2 squared, and that's going to give us a 64 on the right. Now, let's just say I have no idea, again, still, what this is going to be, so I'm going to proceed to try to make it an ellipse. So, I make it an ellipse, trying to anyway, right? Look what happens. A is 2, that's a squared, right? B is, you can't even tell what A and B are because they're the same. So if my A and B are the same, it has to be a circle. Let's look for the center here. 1, negative 2. So I'm going to go over 1, negative 2. This is A squared, right? So my A squared, so A is 2. There's 2, there's 2, and there's 2. And that, ladies and gentlemen, is a circle when you go out the same direction, same distance in every direction. Now, let me show you what we could have done at this point right here, before we did the red divide by 64. Okay? What we would do is we would say, okay, I notice that these coefficients are matching, so I'm going to clean them off. In other words, I'm going to divide by 16. Divide the left side by 16, which means each term, right, by 16 on the right side, and I get this, x minus 1 squared plus y plus 2 squared, and that's equal to 4. And you remember the standard form of an equation of a circle. Standard form of an equation of a circle is this, x minus h squared plus y minus k squared equals r squared. Let's take a look. The center of my circle would be 1, negative 2, and my radius would be 2, and that's exactly what we got by even thinking that it might be an ellipse. Okay? I hope this helps, and I appreciate you watching. Bye-bye.